हेलो फ्रेंड्स, वेलकम यू ऑल हियर। यदि आपने अब तक हमारे यूट्यूब चैनल को सब्सक्राइब नहीं किया है तो अभी दबाएं सब्सक्राइब बटन को। इसके बगल में दिए गए बेल आइकन को दबाना न भूलें ताकि हमारे सारे नए वीडियोस आपको सबसे पहले देखने को मिलें। धन्यवाद।
हेलो स्टूडेंट्स, इस लॉकडाउन में आप लोगों की पढ़ाई का बहुत नुकसान हो रहा है। जैसा कि अप्रैल में आपकी क्लासेज स्टार्ट हो रही थी, लेकिन ये कोरोना वायरस की वजह से लॉकडाउन हुआ और आप लोगों की पढ़ाई संकट में पड़ गई। उसी संकट के घड़ी में आप लोगों तक अपनी क्लास टीचिंग पहुंचाने के लिए ये एक छोटा सा प्रयास है। मैं करीबन एक हफ्ते से प्रयासरत हूँ कि आप लोगों के लिए कुछ ऑनलाइन यूट्यूब में वीडियो बना के डालें और आप घर बैठे उसको चैप्टर को पढ़ सकें। मैं आपके लिए मैथमेटिक्स क्लास 10th के लिए आज वीडियो बनाने जा रहा हूँ। मैं कई दिनों से परेशान था, मुझे मटेरियल नहीं मिल रहा था। मेरे पास आज मटेरियल उपलब्ध है और मेरे पास पुराने पेन थे तो मैं उनका यूज़ कर रहा था। विजिबिलिटी सही नहीं थी और मैं किसी तरह से आज मैनेज करके लाया हूँ मार्कर्स कि हमारे बच्चों को साफ सुथरे क्लियर वीडियोस देखने को मिलें। तो स्टूडेंट्स, ये क्लास 10th का आज हम पहला चैप्टर शुरू करेंगे जिसका नाम है रियल नंबर्स। तो रियल नंबर्स में आज हम आपको यूक्लिड डिवीज़न लेमा से शुरू करेंगे। फंडामेंटल थ्योरम ऑफ अर्थमेटिक पढ़ाएंगे और उनसे संबंधित एक्सरसाइजेस। तो स्टूडेंट्स, उम्मीद है कि आप लोगों को भी ये मेरा छोटा सा प्रयास अच्छा लगेगा। Thank you. Students, you can see first topic is Euclid's division lemma. Students, this name is not new for you, already studied in class 9th. Euclid's postulate, Euclid's axioms, definition. Actually students, you can see Euclid is father of geometry. He wrote books named Elements. Element is not a single book. It is divided in different chapter wise. So it's 7th book. In book Elements, 7th book is for the Euclid division lemma. This Euclid division lemma taken from the 7th book of Element, written by great mathematician, father of geometry, Euclid. So about the number system, one proven statement given by the Euclid, it is given positive integers a and b. You can see these two integers where a is greater than b. There exists unique integer q and r. Satisfying this statement, a is equal to bq plus r, where r stand for remainder, q for quotient, b for divisor, a for dividend. You can see remainder will always less than divisor b and greater than equal to 0. So students, this is a Euclid division lemma. You can see here what is the meaning of this lemma. As I told here the lemma is proven statement and used for proving some other statements. Similarly, you will listen one more word, Euclid's algorithm. So I would like to explain both things here. Now you can see I want to explain about the lemma. A lemma is a proven statement, means no need to prove it, used for proving another statement. So students, it is meaning of lemma, and now I would like to explain about the Euclid's division algorithm. Now see the meaning of algorithm. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Suppose you want to solve any problem, so what step you will take to solve it? So step by step procedure is called algorithm. So you will see it further. I will take some examples in which the meaning of the algorithm will be clear. यूक्लिड डिवीजन लेमा के दो तरह के यूज है। फर्स्ट यूज है कि कोई भी स्टेटमेंट को प्रूफ करना है वहाँ यूज करेंगे, और यूक्लिड डिवीजन लेमा का दूसरा यूज है कि अगर आपको दो इंटीजर दिए हुए हैं और उन इंटीजर्स का आपको एचसीएफ पता करना है, तभी आप पता कर सकते हैं कि क्या होगा, व्हाट इज द एचसीएफ ऑफ। You can see this is exercise 1.1 division algorithm to find the SCF of first part is 135 and 225, second part 196 and 38220, and third one is 867 and 255. So in these three questions I would like to explain first one using the Euclid's division algorithm. So you can see student, for finding the solution of this question, first step we will apply here. Since 225 is greater than 135, applying Euclid's division algorithm to get what we want to get. You can see greater number is 225. This number can be expressed as 135 1 plus, you can see what is getting the remainder. You can see the remainder is getting 90. This is first step of this algorithm. As you know, step by step procedure is known as algorithm. So of this algorithm, this is first step. See step 2 of this algorithm. Since this remainder 90 is not equal to 0, so again you will apply Euclid division lemma to 135 and 90 to get 135 is equal to 90 1 90 plus remainder 135 minus 90, that is 45. You can see here again remainder is not coming 0. So in step number 3 you can see we are considering the new divisor. You can see new divisor is 90 and new remainder is 45. This is new remainder and this is new divisor, and for these two numbers we will again applying the division lemma to get this new step. 90 can be expressed as 45 into 2 plus 45 to the 90, remainder is coming 0. When we will get the 0, we will stop other step, and this last step we will see what is the last divisor. This last divisor will be the HCF of these two numbers 135 and 225. You can see HCF of 135 and 225 is same as HCF of 90 and 45. The remainder is 0, so we will stop our procedure, and in this step you can see divisor is 45. So HCF of 135 and 225 is 45, and this is HCF of these two numbers. And now step by step procedure complete. So we will not say step by step procedure, one word is for it, algorithm. So this is the method how to find the HCF of two number, and two more questions are there. You can apply same method. You continue this process till remainder comes 0. If remainder is coming 0, you stop division, applying the Euclid division lemma, and see what is the last divisor. Last divisor will be the HCF. So you can complete the question number 1, first part, second part, third part from your N.C.E.R.T book. Now see question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. You know, this is a statement ready for proving. We will apply the Euclid division lemma for proving this statement. So you know, in Euclid division lemma, one number is A, another is B. So we will consider here one number A and another number I will consider here 6. So first number is A, second number B is equal to 6. I will take and we will do the all steps. Let A be a positive integer and B is equal to 6. So then there always exist integers Q and R following the Euclid's division lemma. So A will become 6Q plus R. You can see here I have taken A here greater than B. So the value of R you can see less than equal to 6, greater than equal to 0. So you can see different values of A. Number 1, case first. If R is equal to 0, you can write its meaning. The meaning of this one is R may be 0, 1, 2, 3, 4 and 5. Up to 5 only. It means the value of R may be 0, 1, 2, 3 and 4. So one by one case I would like to explain. Case first, if r is equal to 0, a will become 6q. You can see this 6q can be written as 2 into 3q. This is even number. You may see here any number which is written in the 6q form, you can write it is multiple of 2, and any number which is multiple of 2 is called even number. Now come to see second case. If r is equal to 1, you can see that a will become 6q plus 1. R consider as 1. So I would like to explain it as this 6q. You can see 6q is even number. So this means first number 6q is even number plus 1. What you will get if even number is added with 1? You will get the odd integer or odd number. Now you can see the case third. If r is third, if you are r is equal to 2, a will become 6q plus 2. You can see if you are taking common 2 in bracket, what you will get? You will get 3q plus 1. You can see this step, it is multiple of 2, so it will become even number or even integer. Similarly, I would like to explain third step. You can see what it will become. 4. If you are considering r is equal to 3, then the value of a will be 6q plus 3. You can see here, you can rewrite it as 6q plus 2 plus 1. You can write this one is as 2 common, 3q plus 1 plus 1. You can write this part is even integer and this is 1. So it will become odd integer, odd positive integer. Again, some more cases. Case fifth. If you are considering r is equal to 4, then a will become 6q plus 4. Taking common 2, so 3q plus 2, and it is multiple of 2, so it is even integer. Even positive integer. Similarly, last case, case 6. If r you are taking 5, then a will become 6q plus 5. You can see 6q plus 4 plus 1. You can take both together. You can already prove here 6q plus 4. 6q plus 4 is which number? 6q plus 4 is even positive integer. So you can write here even integer plus 1. And you know even integer plus 1 becoming odd integer. Now in each and every cases you can see in which cases number is coming even and in which cases number is coming odd integer. So first case you can see, one case is here. If you are taking r is equal to 5, you are getting odd integer. If you are taking r is equal to 3, you can see r is equal to 3 written here. It is also the case of odd integer. And if you are taking r is equal to 1, r is equal to 1 is also case of odd integer. So you can see question number 2 is saying same thing. In the last you will write conclusion. After adopting these steps, ultimately in the last you will write these lines. Now it is clear that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer, hence proved. You must write this last line, conclusion of the solution. Okay, so this question number 2 solution completed. So students, question number 1, question number 2, we have seen that their solutions. And here question number 3, I am not solving here for you. You will read it carefully. It is given just in the book. So I would like to read this question number 3. An army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So you can see maximum number of column. One word you identify maximum. It shows you find the SCF of these two numbers. One number is 616, another number is 32. So you will find the SCF of these two numbers using Euclid division lemma as you have done in question number 1. So now come to the question number 4. In the book, question number 4 is this: use Euclid division lemma to show that the square of any constant integer is either of the form 3m or 3m plus 1 for some integer m. See its solution. Again we will apply the Euclid division lemma. So in lemma, one number is a, another number is b. So there always exist two integers q and r satisfying the condition a is equal to bq plus r is less than b and greater than equal to 0. So same thing you will consider here. Let a be a positive integer and we are considering here b is equal to 3. We are considering b is equal to 3. So using Euclid's division lemma, there always exists, you know, a is equal to bq plus r. So in place of b, I have considered here, in place of b, I took 3. Here you can see the value of r is less than 3 and greater than equal to 0. So students, you can see different cases. It means the value of r will be maybe 0, 1, 2. These three values, either of these three values will become of r. So now one by one case I would like to explain. You can see here, first case first, If r is equal to 0, value of a is equal to 3q, but we need square of a. Square of a means a square. The value of a square will become 3q square. It can be written as 9q square. Now see here, this 9q square can be written as 3 inside the bracket 3q square. 9q square can be written as 3 common, so 3 3s are 9 and q square in bracket. So outside 3, inside the bracket 3q square. So 3q square can be written as m. You can see here for some positive integer m. So you can see it is coming 3m. So first thing is prove the square of any positive number is of the form 3m. Now further, if we are considering the value of r is equal to 1, case second, if we are taking r is equal to 1, a will be 3q plus 1. So square of a, you can see square of a is equal to a square, and a square will be square of this one, 3q plus 1 whole square. This can be expanded using a plus b whole square. So 3q square plus 2 into 3q into 1 plus 1 square. Now I am going to simplify it. This can be written as 9q square plus 6q plus 1. We want to write it in the form of 3m plus 1. So taking common as 3 in these two 1. So taking common 3, 9q square plus 3 3s are 9. So you write here 3. 3 2s are 6, so 2. And inside bracket q plus 1. You can now convert it in the form of 3m plus 1 for some positive integer m. So you can see if we are taking r is equal to 1, so square of the number will be 3m plus 1 form. One more case is there, case third. In case third, you can consider r is equal to 2. In case third, you can see taking r is equal to 2, then a will become 3q plus 2. Now we will write square of a is equal to square a square, and a square will be square of 3q plus 2 whole square. This can be written as 9q square plus multiplication a square plus 2ab plus b square. So here 3q into 2, 6q and double 12q. I am writing here directly, plus the square of 2 is 4. Now we will write it in this form 12q plus 3 plus 1. Now taking these terms, you can see here in the last 4 is here. 4 is expanded in the form of 3 plus 1 and 3 is taken with these terms. Now taking common 3, in bracket you will get 3q square plus 4q plus 1 plus 1. Now you can see this is 3 and this bracket will become positive integer m and plus 1. So ultimately you can write it as 3m plus 1. You can write here for some positive integer m. Now you can see student, after this we will write same sentence what is given in the question in the last. So students, after explaining, ultimately you will write, it is clear that square of any positive integer is either of the form 3m or 3m plus 1 for some integer m, hence proved. As you have done the question number 4, in the same way you can solve question number 5 of exercise 1.1. So let us see how to do question number 5. Question number 5. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. So see its solution. Let a be a positive integer and b is equal to 3. Then using Euclid's division lemma, a is equal to written as 3q plus r. Here r is less than 3, greater than equal to 0. So you can see it of r may be 0, 1, 2. These three values. So one by one case I will consider. First of all, case first. If we are taking r is equal to 0, value of a is equal to, you can see here we are putting the value r is 0, so the value of a will become how much? 3q. Now we want to find here cube. Cube of a means a cube. So now you do the cube of this 3q. So 3q whole cube you can write 27 q cube, and 27 q cube can be written as, you can see taking common 3, in bracket you can get 9q cube, so you can write here 3m. So you can take out 9, so in bracket you will get 3q cube and you can write it as 9m. You know q is integer, so cube of q is integer, its thrice is also integer, so this whole bracket will become some positive integer and I am considering that positive integer is m. So in bracket you must write for some integer m. This is case first. Now come to see the case second. Case second is saying if r is equal to 1, a will become 3q plus 1. Now a cube, the value of a cube will become 3q plus 1 whole cube. Now applying the cube formula, a cube means 3q whole cube plus 1 cube plus 3 into 3 cube into 1 in bracket 3q plus 1. Which formula applied here, you just see. I would write this one, a plus b whole cube formula applied here. So a cube plus b cube plus 3ab in bracket a plus b. This formula is applied. You had studied this formula in class 9th. So now simplifying it to get next line, cube of 3 27, cube plus 1 plus it is 9 cube. 9 cube multiplied with 3 cubes, so 9 3 are 27. 27 q square. And 9 cube multiplied with 1, so it will give 9 cube. Now rearranging, I am going to rearrange this line. You just see how we will rearrange. After this line, I am going to rewrite this one here. A cube is written as 27 q cube plus 27 q square plus 9 q plus 1. Now taking these all three terms together, taking common as 9, so 3q cube plus 3q square plus q plus 1. You can see this bracket q is integer, so q being multiplying by 3, squaring multiplying by 3, it is integer, it is also integer, it is also integer, sum of all integer is again integer, and I am considering this bracket as m, and for some integer m. Now see case 3. Its third case is if you are taking r is equal to 2. So the value of a will be 3q plus 2. But we want to find the cube of a. Cube of a is equal to a cube, and it can be written as 3q plus 2 whole cube. Now cubing, again applying formula a plus b whole cube. So cubing this one, 3q whole cube plus 2 cube plus 3 thrice of a into b, so 3 cube into 2 in bracket 3 cube plus 2. In the next line, I am going to simplify last one, this one, 27 cube, it is 8, this one is 9 to the 18, 18 multiplying this one, 18 3 is 54, 54 q square. Now here 18 to the 36, 36 q. Now rearranging, after rearranging we can rewrite it as plus 54 q square plus 36 q plus 8. Now we are taking first these three terms all together. To take the common 9, so 3q cube plus 6q square, 6 9 ja 54, yes, plus here 9 common, so 4 cube plus 8. You can see this bracket can be again integer, so you can write it as 9m plus 8. So you can see students, this case is also coming. Previous case is, first case is was the in the form of 9m. Second case was of this 9m plus 1, and this case third is coming 9m plus 8. So ultimately in the last you will write the same sentence, you will repeat up to this. Here you can see the last line of the question will become, you write here, it is clear that. It is clear that already written. It is clear that the cube of any positive integer is of the form m, or 9m plus 1 or 9m plus 8, hence proved. So student, ultimately you can see exercise 1.1 completed. Here once more I would like to explain, these 4 and 5 questions generally comes in board examination. Question number 2 is very important, so you must revise well, and next day I will discuss about the fundamental theorem of arithmetics. And dear students, I hope this is my first video class for class 10th and exercise 1.1. I hope you like it very much, and please share with your other friends so that they can get the benefit and they can prepare for coming board examination 2021. Jai Hind.